So we know from yesterday that a number line with fractions looks something like this. When you are a fourth grader, where does every number line start?
0.
0. But when you have fractions, it can end anywhere. Well, really, anything you have. It can end anywhere. So, say, let's see. Zari, what should I break my number line into? What fraction should I use? What or how many pieces should I break my whole number line into?
5.
5. So here's the beginning of my first piece. And the end. So there's 1, 2, 3, 4, 5. When I'm breaking my number line up, do I count the tally marks? Or the tick marks, sorry? No, because look at this. 1, 2, 3, 4, 5, 6. Oh, okay. This is 6. But uh-oh. I don't have enough. Because where does my number line always start when I am a fourth grader doing fractions?
0.
0. Not at 1/6. So I can't count this tick mark when I'm counting the parts. Otherwise, I end up here. And is that all of the pieces? Like if I have I'm going to do a square because, and if I shaded that, is that 6 out of 6, which we know is how we ended it? No, because when I am labeling my number line, this is a review from yesterday, I'm not counting the tick marks. I'm counting the spaces between the tick marks. 1, 2, 3, 4, 5. So if I broke my number line into 5, I know I'm going to start with 0, and I'm going to end with 5/5. My first tally mark after the 0 tick mark is going to be 1/5. The second tick mark after the 0 is going to be 2/5. The third tick mark after the 0 is going to be 3/5. And the fourth tick mark after the 0 is going to be 4/5. So I have my shape, and we're going to pretend that this is 5 equal pieces. We're going to pretend. It's not, because I'm not a perfect artist. If I shaded 5 out of these 1, 2, 3, 4, 5 pieces, this is what it would look like. 1, 2, 3, 4, 5. How much is shaded? Carla?
5/5.
5/5. How else could I say what's shaded? Lena?
1 whole.
1 whole. All of it. 1 whole. The whole shape is shaded. So we can say that 5/5 is the same as,
1 whole.
and remember all of our number lines yesterday, when it got to the very last one where the numerator and the denominator were the same, it did that little outline of a 1. To show you that 5/5 is the same as 1 whole. Well, that's basically half of our lesson today. When your numerator and the denominator are the same, that means your whole shape is shaded. So if the numerator and the denominator are the same, it is equal to 1 whole. This is not equal to 5. Do I have 5 shapes shaded here? No, I have 5 pieces of 1 shape shaded. If I had 8 eighths, I have my pizza. It's broken into 1, 2, 3, 4, 5, 6, 7, 8. If I shade 8 out of those 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8, and pretend that's what I ate. Did I eat 8 pizzas? What did I eat? Michaela?
8 pieces.
8 pieces of how many pizzas? 1. So if your numerator and denominator are the same, it's equal to 1. Not 5, not 8, not 6. Because this just means I have 8 out of 8 pieces shaded. 6 out of 6 pieces shaded. 5 out of 5 pieces shaded. Not 5 holes or 6 holes or 8 whole pizzas, but out of 8 pieces. So, Zadie, read the sentences at the top of the page under the title.
Whole numbers can be written as fractions. When the numerator is the same as the denominator, the fraction equals 1.
Put a box around that. When the numerator is the same as the denominator, the fraction equals 1. Or just underline it. It might be easier to just underline it. When the numerator is the same as the denominator, the fraction equals 1. Which number is the numerator? Cullen?
The bottom of the number that is on the bottom.
Nope. What's the handy trick that we can remember to remember where one of them is? Zadie?
The denominator has D at the beginning, which stands for down.
So that means the denominator is
On the bottom.
on the bottom. Remember, denominator has a D. Down starts with D. So the denominator is down below the, gotta know these words. Carla? Numerator. So the numerator is where, Carla?
On top of the denominator.
On top of the line. The denominator is where? Michaela?
Down below.
Down below. Denominator is down. Sit up straight. Okay, so if the numerator, top number, and the denominator, bottom number, are the same, the fraction equals 1 whole. Everybody, finger or pencil on example 1. And read in your head while I read out loud. There are 4 panes of glass in one window of Landon's classroom. So I'm picturing a window like this. You know, 4 panes, 1, 2, 3, 4. You know how on a window, we don't really have the same type of windows, but panes are when you have these like wooden or plastic pieces that cross. And each little piece is 1 pane. So, there are 4 panes of glass in one window of Landon's classroom. Each pane of glass is 1/4 of the whole window. So, how many fourths equal 1 whole? Well, if we look at this window, how many panes are there? There's 1, 2, 3, 4. So that means just 1 pane is 1/4 of the whole window. 1 pane out of the 1, 2, 3, 4. So this 1 pane represents what fraction? Just this one. Lena?
1/4.
1/4. And what about this one? Smith?
1/4.
1/4. And what about this last one that we haven't written on yet? Victoria? 1/4. So each pane of glass is 1/4 of the whole window. This is 1/4, this pane is 1/4, this pane is 1/4, and this pane is 1/4. Now we need to figure out how many fourths equal 1 whole. So we have our number line. Our first pane of glass takes up 1/4. If we add another pane of glass, well, now we've taken up 2/4. If we put another pane of glass on there, we end up at 3/4. And then if we put the last pane of glass on our number line, we end up at, Cullen?
4/4.
So, how many fourths equal 1 whole, Cullen?
4.
4 fourths equal how many holes?
1.
1. We have 4 panes of glass. Does that mean we have 4 windows? No, it just means we have 1, 2, 3, 4 panes of glass in 1 window. So, the fraction looks like this. We have 4 parts, 1, 2, 3, 4, out of a whole that is broken into 1, 2, 3, 4 pieces. Remember, the denominator is, so the denominator, denominator, equals the pieces in the whole, the total. So the denominator is the total pieces in the whole. So like our whole pizza was cut into 8 pieces. Our whole window has 1, 2, 3, 4 panes. So the denominator is the number of pieces in the whole. The numerator just shows the parts of the whole. So what's shaded, or how many are you counting out of the whole? So this is the numerator. Numerator is spelled N-U-M-E-R-A-T-O-R. And it stands for not the total pieces in the whole, but pieces of the whole that you are looking at, or what you're working with. How many pieces of pizza out of the 8 total did you eat? How many panes of glass out of the whole window are you looking at? Okay, let's look at the bottom. Please make sure you're not drawing. It says, place a point. This means graph or plot a point. Place a point means the same thing as graph a point or plot a point on the number line to graph this fraction. The models show that 4 fourths and 1 share the same point and have the same size. So, if we want to show this fraction on our number line, are we going to put it at the 0 tick mark? Show me. Some of you are not listening because I don't see you moving at all. If we're trying to show this fraction, 4 fourths, are we going to put it at the 0 tick mark? What about the 1 fourth tick mark? What about the 2 fourths tick mark? 3 fourths? 4 fourths? And we can see that 4 fourths and 1 share the same point, which means they're the same size, right? If you're plotting something and it has 2 labels, well, that means those labels are the same. So 4 fourths equals 1 whole, or 4 fourths equals 1. So if your numerator, what this is all trying to tell us is that if your numerator and your denominator are the same, it's equal to 1. Not whatever the numerator and denominator are, but 1. We do something different to show that we have 6 holes, or 5 holes, or 8 whole pizzas. We do something different. We show that fraction differently. Does everybody understand example 1? Okay, let's move on to example 2. Helper number 1, please sanitize, erase, sanitize. You can leave this here. Okay, so let's look at the sentence at the top. the fraction 1, and we call that a whole. When there's a 1 on the bottom, we say whole. We don't say 1, we say whole. So remember, when we say fractions, we say the top number, and then we say the bottom number with th at the end, or unless it's a 1, in which case we say 1 whole. If it's a 2, we would say top number half or halves. If the bottom number, the denominator, is 3, we would say top number third or thirds. The rest of the numbers, you just say that number with the th at the end. So the fraction 1 out of 1 means 1 whole. So 1 whole partitioned into one group. Partition means broken up or made into parts. Not broken up, but cut into pieces. So 1 over 1 equals 1 whole. Remember, if a 1 is at the bottom, we say that as whole. Not 1, but whole. So 1 whole, here's our fraction bar, or just this pizza. Well, imagine this is a pizza. How many pieces is it cut into? Oh, this is one counter in one group. Whatever. But imagine we also have a pizza, and we haven't cut it. Here's your pepperoni. Looks more like a cookie, but whatever. We haven't cut it yet, so it's 1 whole pizza. We have not partitioned it into groups. We haven't cut it into pieces. So, everybody, finger, pencil, and example 2. It says, how many wholes are in 3 over 1? Well, what do we say when a 1 is a denominator? Carla?
1 whole.
Whole, not 1 whole, but whole.
Whole.
Just like if we have this, we don't say 1/3. We say the top number and then third or thirds. So if a 1 is the denominator, we call it a whole. So if we read this the way we would read this, we read the top number, which is what, Carla?
3
3, and then we say what the bottom number represents. So 3
whole.
wholes. Well, knowing that when there's a 1 on the bottom, you say the word whole, how many holes do you think are in 3 wholes? Zadie?
3.
3. Because if we have 2/3, then we know that means we have 2 thirds. So if we know that when a 1 is the denominator, we say the word whole, we know that 3 over a whole would be 3 wholes, which is 1, 2, 3 wholes. So here, look at this right here. We have 1 counter in one group, or 1 pizza, to represent 1 over 1. Because our 1 whole is cut into how many pieces? 1. It's 1 piece. We can't say 0 because then that would mean we have no pizza. Do we have no pizza here? No, we just have 1 whole massive pizza. So if we imagine 3 wholes, we can imagine 1 pizza, 2 pizzas, 3 pizzas. So there are 3 parts, but there's 1 whole. That means we have to have 1, 2, 3 which means there are 3 holes in 3 holes. So basically, let's look at the key concept box. Usually we look at that first, but I thought with this lesson it would be easier if we figured out why first, and then we look at the easy way to remember. So look at the first part of the key concept. It says, if the numerator and the denominator are the same, the fraction is equivalent, which means equal, to 1. So here we have 3 thirds, which is equal to 1 whole. If the numerator and the denominator are the same, it's equal to 1 whole. Let's add a few more examples. Carla, what's another fraction that is equivalent or equal to 1 whole? 9 ninths. I'm going to pick 2 more people. Lena, what's another fraction that's equivalent to 1 whole? Be thinking of what you want your fraction to be if I pick you so we can go quick. It's a countdown. 5/5. Come on, guys, just because the numerator and the denominator is the same doesn't mean you say it any differently. You say the top number, 5, and the bottom number with, or th at the end, 5/5. You guys have no problems when it looks like this, so I don't know why when you have to say this, it all of a sudden becomes a problem. You say it the exact same way. This would be 2/5. So if we replace that 2 with a 5, it's just 5/5. Okay, tell me one more. Make sure you have one in your brain. Mason, what's one more fraction that's equivalent to 1 whole or equal? 3/3. Okay, now let's look at the concept on the bottom. If the denominator is 1, that means the bottom down below is 1. The fraction is equivalent to the whole number represented by the numerator. So if the denominator, the number down below, is 1, then that fraction is a whole equal to whatever the numerator is. So if we have 3/1, 3 wholes, it's equivalent to 3. If we have 6/1, or 6 wholes, it's equal to what, class?
6.
If we have 156/1, 156 wholes, we have 156. Give me one more example. Kingston's not in here. Be thinking so that when it's your turn, you know exactly what to say. Colin.
4/1.
How do we say that? So 4/1, and we say it as, how do we say that fraction?
4.
How do we say when 1 is at the bottom? How do we say that? Do we say 1?
4 whole.
4 wholes. So 4 wholes is equivalent to 4. Okay? And then they point out that these are number sentences. So 3 wholes equals 3 is a number sentence. 3/3 equals 1 is a number sentence. Even though we don't have an operation symbol, when it's fractions, we don't actually need that. As long as we're talking about whole numbers. Other ones, you can't do that. Okay, so does everybody understand this first concept, where if the numerator and the denominator are the same, the fraction is equal to 1? And this bottom concept, where if you have a 1 as the denominator, the fraction is equal to whatever the numerator is, the wholes. Does everybody understand that? Okay, let's move on to the guided practice. Okay, so for the guided practice, they're giving us pictures. And we have to write a fraction to represent the shaded part of each whole or set of wholes. So in number 1, we have a square shape. Victoria, how many squares do we have? 4? How many total separate squares do we have?
8.
1. First of all, these aren't squares. These are triangles. And we're not doing one of those brain teasers where it's like, how many squares can you see? Because are they separate? Are they separate? Like, are they separated? Is there space between them? No, we have 1 square. So how many holes do we have here? Carla?
1 whole.
1 hole. We have one square, so we have one whole. But it's broken up, right, Victoria? How many pieces is our one whole broken into? 8. 1, 2, 3, 4, 5, 6, 7, 8. So our one whole is partitioned or broken up into 8 pieces. How many of those 8 pieces are shaded, Victoria? 8. So we know 1, 2, 3, 4, 5, 6, 7, 8 out of 1, 2, 3, 4, 5, 6, 7, 8 pieces are shaded. So 8/8 is equivalent to what, Victoria?
8. Oh, wait.
Please look at the key concept box. Please. This is where a lot of you are going to be wrong just because you just like guess real quick and you don't think. 8/8 is equivalent to 1 whole. Otherwise, you're telling me that there are 8 squares here. Is that true? No. 8 out of 8 triangles are shaded. So if you only have one shape, are you going to be looking at the first key concept or the second key concept? If you have one separate shape, are you going to be looking at the first key concept or the second key concept? Smith?
The first.
The first, because we only have one shape and it's broken into pieces. So that tells us the denominator is the total number of pieces. There were 8, 1, 2, 3, 4, 5, 6, 7, 8 pieces. The numerator, the top number, tells us how many of those pieces are shaded. Well, 1, 2, 3, 4, 5, 6, 7, 8 were shaded. So that means 8 shaded pieces out of 8 total pieces were shaded, which is equivalent to 1. Now, let's look at number 2. Smith, how many separate ovals do we have?
4.
4. Are any of them broken up?
No.
No. So each of these ovals is broken into how many pieces?
1 piece.
1 piece. Because look, it's not 0, because we still have some. If it was broken into 0 pieces, that means it wouldn't exist, but it does. So each of these ovals is broken into 1 piece. Well, how many do we have?
4.
4. So that means we have 4 ovals. Each of them is whole. They're not broken up. So how many holes do we have?
4 holes.
4 holes. So if you get to the problem and there are separate pieces, there's not one piece all by itself, are you going to be looking at the first key concept or the second key concept? If you get to a problem like this where there are separate pieces, are you going to be looking at the first key concept or the second key concept? Zari.
The second key
The
concept.
second key concept. First key concept matches with example 1. Second key concept matches with example 2. Number 1 matches with example 1. Number 2 matches with example 2. Okay, let's look at the independent practice, and we'll do a couple of them together like we did yesterday. Helper number 1, please sanitize, erase, sanitize. Okay, we're going to do 3, 4, and 5 together, and then you're going to do 6, 7, and 8 on your own. Okay, so the directions for this part say, write a fraction to represent the shaded part of each hole or set of holes. So number 3, Michaela, what shape are we looking at?
The circle.
A circle. How many circles do we have in number 3?
1.
1. So are we going to look at the first key concept or the second key concept?
The first key concept.
The first key concept, which tells us what?
Hear me read it.
Yes.
If the numerator and the denominator are the same, the fraction is equivalent to 1.
So, we have our one circle, but it's partitioned or broken up into pieces. How many pieces is our one circle broken up into?
4.
4. 1, 2, 3, 4. Out of those 4 pieces, how many are shaded, Michaela?
4.
4. So, how many total circles are shaded?
1 whole.
1. 1 whole circle. We have our one circle, and it's partitioned or broken up into 1, 2, 3, 4 pieces. There's where we get our denominator. Our numerator tells us, well, how many of them are shaded? 1, 2, 3, 4. All 4 are shaded, so the whole one whole circle is shaded. Good. Now number 4. Aaron, what shape are we looking at? Triangles. How many triangles are there?
2.
No, 2. So are we going to be using the first key concept or the second key concept? The first, where we have just one shape that's broken into pieces. Aaron, remember, example 1, listen, example 1, the first key concept and number 1 all match. Example 2, the second key concept and number 2 all match. Does this look more like example 1, first key concept and number 1? Or does it look more like example 2, second key concept, number 2? Example 2. So that means we're going with the second key concept. We have 2 separate triangles, whereas here we only had one circle. Now we have 2 separate triangles. Well, let's look at one triangle. How many pieces are they partitioned into? Are they broken into? 1. So our denominator is 1, because each triangle is only broken into one piece. But how many triangles are shaded? 2. So that means we have 2 triangles. They're each only broken into one piece. So how many triangles do we have? 2. Okay, number 5. Carla, does this look more like example 1, first key concept, number 1? Or does it look more like example 2, second key concept, number 2?
Number 1.
Number 1. We have, what shape are we looking at?
A rectangle.
Rectangle. How many rectangles do we have?
2. 1.
Because look, how many, do we have space between our rectangles like we do here?
No.
No, so we have one big rectangle, but it's partitioned or broken up into how many pieces?
2.
2. So our one rectangle is broken into 2 pieces. How many are shaded, Carla?
2.
2. So that means 2 out of these 2 pieces are shaded. So how many rectangles are shaded, Carla?
1.
1. One whole rectangle. Not two rectangles, because there's no space. So that means it's just one whole. Notice the difference. Is there any space between these pieces?
No.
Is there any space between these pieces?
Yes.
Is there any space between these pieces?
No.
So do you see the difference? Now, I'm going to give you about a minute to do number 6, 7, and 8. Pay attention. Does it look more like number 1 on the guided practice or number 2 on the guided practice? Okay, so number 12. We have 1. Smith. 1 is equivalent to what fraction? What is our numerator?
3.
This time it matters
Okay.
because we're following the same rules that we followed for numbers 9, 10, and 11.
1.
1. And our denominator?
1.
1. Now, we're not going to do what I said a minute ago, what I did on numbers 9, 10, and 11, because this would still be the same. We have one whole piece. It's broken into one piece, and that one piece is shaded. It's the same. But number 13 is where that changes. Cullen, we have 8. 8 is equivalent to what fraction? What's our numerator?
8.
8. And what's our denominator?
1.
1. Not 8/8, because 8/8 means you have one whole. It's broken into 8 pieces, and 8 of them are shaded. Cullen, 8/8 is equivalent to
1 whole.
1. 8 is equivalent to 8 wholes. Number 14, we have 3. Mason, what does our fraction look like? What's our numerator? 3. And what's our denominator? 1. Not this. Because that means you have one whole, it's broken into 3 pieces, and all 3 of those pieces are shaded. Mason, 3/3 is equivalent to 1. Watch out for that. Okay, numbers 15 through 18. We're going to do 15 and 16. You're going to do 17 and 18 on your own. It says, find, and then you're going to do number 19 on your own, which you should all know how to do at this point. So really, once we do 15 and 16, you're on your own for the rest of it. Number 15, it says find the missing numerators and denominators. Then circle the model that is not a fraction for one whole. Zadie, how many shapes, how many separate shapes with space between them do we have? 0, there's nothing there, it's just a blank spot.
No.
How many separate shapes without space do we have here? 1. That means we have to count how many pieces there are. How many pieces is our one rectangle broken into, Zadie? 6. 1, 2, 3, 4, 5, 6. So that means our denominator is 6. Okay. If this is happening and Zadie's the one calling, then somebody else needs to go into the door. Aaron or Carla.
Sorry to interrupt.
Hey, oh, that's okay. Thank you.
Here, buddy. Thought you might be more comfortable. All right.
Thank you. So if Zadie's helping and there's some, Carla or Aaron, you go grab the door for her, okay? Okay, now our numerators, how many are shaded? Well, we have 6 pieces, 1, 2, 3, 4, 5, 6. How many are shaded? 5, so that's a little different. Okay, number 16. Smith, how many separate shapes with space between them do we have here?
1.
1. But it's broken into pieces. How many pieces is our one shape broken into?
4.
4. So what's our denominator?
4.
4. How many of those 4 pieces are shaded?
4.
4. Let's just tell ourselves 4/4 is equivalent to
1 whole.
1 whole. Is 5/6 equivalent to 1 whole?
No.
Is 5/6 equivalent to 5?
No.
No, 5/6 is just 5/6. Okay, let's just do 17 and 18, and then you'll have the rest to do tonight, or later today if we have time. Zari, number 17, we have another trapezoid. How many separate shapes with no space between them do we have, Zari?
3.
Is there space?
No.
No, so how many separate shapes with no space between them do we have,
1.
Zari? 1. And it's broken into how many pieces?
3 pieces.
3 pieces. So what's our denominator?
3.
3. How many out of those 3 pieces are shaded?
3 of them.
3. So we have 3/3. Let's tell ourselves it's equivalent to
1 whole.
1. Okay, I want to tell you something really quick because I don't know why you guys keep doing this. When I ask the question, how many shapes do we have with no space? Well, and you tell me 3. I don't see any space. What are you talking about? Do you know what the word space means? Because if not, then we need to talk about that. Or are you just not listening to my question? And you're just guessing real quick. You've got to listen to the question, and if you don't know what the word space means, well, then we need to have a chat. Okay, number 18. How many separate shapes with no space between them do we have? Aaron. How many separate shapes with no space between them do we have? 1. But it's broken up. How many pieces is it broken into? 2. So what's our denominator? 2. Now our numerator. How many of those pieces are shaded? 2. 2 halves is equivalent to 1 whole. So let's look at the second part. We did the first part of the directions. Find the missing numerators and denominators. But the second part says, then circle the model that is not a fraction for 1 whole. Michaela, are any of these models not a fraction for 1 whole?
Yeah.
Yes, which one?
5,
How do we say that?
5, 6.
5/6. So which problem are we going to circle?
5, 6.
Which problem?
Oh, number 15.
Number 15. Because 5/6 is not equal to 1 whole. Is this whole shape shaded, Michaela? No, a piece of it is missing. Okay, actually what I'm going to do, since we are on our long story and we have 2 days to do our long story, I'm going to go ahead and give you 15 minutes to do number 19 and the rest of the independent practice. Look at page 610. These are word problems where you are just figuring out, okay, what are they asking me? Are they asking me for how many wholes or how many parts of a whole? If they're asking for how many wholes, you're going to have a fraction that looks like numbers 9 through 14. If they're asking for parts of a whole, if they're asking for the number of wholes, it's like this. If they're asking for the parts of a whole, it's like 16, 17, 18. So make sure you're paying attention. Listen to the words. They may not say how many parts of the whole, but they may say something like how many pieces of the whole pizza, or how many pizzas. So listen for that. Pieces of, parts of, versus just pizza. Okay? Number 22 and number 23 are critical thinking with numbers. And number 24 is critical thinking with words. Look at your homework. Numbers 1 and 2 are just like the first part of the independent practice, where you have to figure out, okay, how many total separate shapes are there with space between them? Then figure out, are you doing it like the first key concept box? Like the first key concept or the second key concept? Numbers 3 and 4 are the same as numbers 1 and 2. Numbers 5 through 8 are just like 9 through 14 on the independent practice. And then numbers 9 and 10 are just our word problems. And number 11 is one of those test practice where you have to figure out what matches. It's multiple choice. Any questions about homework or independent practice? Do not tear off your homework until tonight or tomorrow when you're turning it in. Go ahead and finish number 19 and then work on the back. You're going to have 15 minutes.